Hi, pre-calculus. Let's take a look at page 25 in your packet so we can review some basics of transformations. When you see these little graphs like this was from the beginning, the first lesson that we did, where it was just can you identify the function? There's clearly no stretching or shrinking because there's no points. They just want you to get the basics down here. Okay, so for the first one, I'm noticing that it is a parabola, which means my equation needs to be x squared. I'm also noticing that the regular parabola, which if I just draw a dotted one like this, okay, has been reflected over the x-axis. So we have to get a reflection over the x-axis in our equation. Okay, and the way that we do that is we put a negative. Where do we put that negative? Does it go out in front or inside? That's right, it goes in front. Okay? All right, what else do I notice? If I just reflected this parabola down, it would be right here. So I'm noticing that this vertex got shifted 1, 2 to the right. So the parabola has been shifted 2 to the right. Okay, and a horizontal translation goes inside the function. Okay, an important thing I want to make sure everybody understands is that an equation needs to have an equal sign. So f of x equals, okay, without that it's just an expression. I need to make sure that I do a parabola, an x squared function, with a negative out in front. Okay, so we have a negative. And then when we shift 2 to the right, horizontal translation is going to go inside. Okay, so we're going to have x, and then the 2 quantity squared. Okay, but wait a minute, when you shift 2 to the right, we're going to put a minus sign. Okay, so do I have a squared? Yes. Reflect over x-axis. Got it. Shift 2 to the right. Perfect. Okay, so these were just asking, can you identify basic transformations by looking at where they usually start and what happened? For number 2, this one is a cubic, so I need to do an x cubed function. Okay, I'm going to go ahead and find that middle point, which seems to be right here. So a regular cubic usually has his starting point right through the origin. Okay, so what happened here? It got shifted 2 to the right, and it also got shifted 2 units up. Okay, there's been no reflections that I can tell. I guess it could have gotten reflected and then looked like a regular one, but most people say they just do the basic as simple as they can without adding extra transformations. Okay, so let's start off with f of x equals x cubed. To do 2 units right, okay, that's going to go inside or outside the function? That's going to go inside. And then 2 units to the right, you're going to say minus 2, okay, cubed. To say 2 units up, that goes after the function, and that's going to be plus 2, just like you'd expect. Okay, this last one right here, I noticed that it is a v, so this is going to be an absolute value equation. The regular absolute value used to be facing up with the vertex on the origin. Okay, so I see a reflection. And you can't just say reflection. Okay, you have to say which axis. Since it got flipped down, this is a reflection over the x-axis. That would just put the v here. So it also got shifted 2 units to the left. Okay, I need to make sure that I have y equals, or f of x equals. I need to make sure I have an absolute value function. 2 units to the left, that would be plus 2. Oh wait, I forgot reflection over x-axis, and that would be a negative out in front. Okay. All right, let's take a look at these next ones. Can you name and then graph these basics? Okay, so now we're talking looking back in your notes on page 1. Okay, looking back on page 1, what is the name for something like f of x equals b? Yeah, that's called the constant function. Constant function. Sometimes people tell me it's helpful for them to think of this in terms of numbers. So like an example of one, f of x, I could call it y equals number. Oh, it's kind of like a y equals 4. Okay, f of x equals b is a horizontal line. He's constantly straight. So I'm going to draw a nice horizontal line, okay, with some arrows intersecting right there at point B. Okay, so what happens as you go one to the right? One to the right, nothing. He's constantly at the same value. He's not increasing, he's not decreasing. What does f of x equals x? What's his name? What function is that? That's called the identity. Identity, okay? It's like y equals x. Y equals 1x. The slope is 1, okay? So he starts at the origin. Up 1 over 1, up 1 over 1. Okay, he's called the identity because at value 1, 2, 3, 4, 5, he's got a y value of 1, 2, 3, 4, 5. Okay, please put points all the way off the graph paper. Same thing this way. Okay, he's a nice diagonal line. This is the line y equals x. At value negative 5, negative 5. Negative 6 gives you negative 6. Please draw a nice line, okay, with arrows. Okay, the work for this chapter is all of the points that I can see. What is this one called? Yeah, that's called the reciprocal function. Okay, reciprocal function. We're not going to do too much with the reciprocal function this chapter in terms of graphing point by point. We'll do a whole nother chapter on that. Okay, but what I do want you to know, okay, is he's got two branches, he's got two arms. 1 comma 1 is one of the points. Negative 1, negative 1. Okay, and then this is asymptotic to the y-axis and the positive part of the x-axis, and then over here asymptotic on the left side and the bottom side. Okay, he's got two branches, and those are the points I want you to graph. Okay, make sure you study the rest of the graphs from that page, not just these three. This was just an example. Okay, let's take a look at this one. Okay, so now we're getting into some juicier stuff. Describe the transformations that were performed on this equation. Okay, so I see a parabola, and then we have to graph. Okay, so let's go ahead and state all the transformations. Okay, so number 1, I see a negative out in front. A negative out in front means a reflection, but you have to make sure you say which axis that is. Since it's out in front, it's going to be a reflection over the x-axis. Okay, number 2. The order of these statements really matter too. I see a 1/2. Okay, if it's out in front, is that vertical or is that horizontal? That's vertical. Okay, you have to say the word vertical. And is it a stretch or a shrink when you see 1/2? It's a shrink. Okay, by how much? A shrink in half. You have to say the word vertical. You have to say the word shrink. Oops, did I forget the N? And you have to say by how much? By 1/2. Okay, step number 3. I see -5. That means that we're going to shift this parabola 5 units to the right. Okay, I also see after the quantity squared, I see a +3. So the 4th step, I have to shift this parabola 3 units up. Okay, you could also say vertical shift or vertical translation 3 units up, but bare minimum, I have to see the number 3 and I have to see which way. Okay, those are all the transformations. The second thing that we're going to do is take a look at the growth chart for a parabola. Okay, so how does the parabola usually go? In terms of over and up, it's usually over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. Okay, now that's the regular one. Do we have any stretching or shrinking? We sure do. We have a vertical shrink. Okay, which numbers are the verticals? The ups. I have to shrink all of these in half. Not a 3, but 3/2. Not a 5, but 5/2. Okay, then 7/2. Okay, I think I've got all my steps. I've got my growth chart. Okay, let's just remind everyone what a regular parabola would look like. Okay, a basic parabola would be opening up like this. So when I reflect it over the x-axis, it's now opening down. Okay, so there's the reflection. In terms of shrinking, I can take care of that once I get it to the right place. So let's go 5 to the right and 3 units up. 1, 2, 3. Okay, so the vertex is going to go right there. There's the vertex. It's going to be growing down, opening down. Okay, now I'm going to use my growth chart to make really nice points. Over 1, down 1/2. Okay, so I want to see these half points right there. Over 1, down 3 halves. So that's half, half, half. That's 3 halves, or 1.5. Okay, so you should be right there at 7, comma 1. Same thing this way. Over 1, down 1, 2, 3 halves. Okay, the half takes you to a full box, and then one more. All right, over 1, down 5 halves. 5 halves is like 1, 2.5. 1, 2.5. Okay, so every other point will be on a corner of a box. All right, let's do it again. Over 1, down 7 halves. 7 halves is like 3.5. So the half fills the box, and then 1, 2, 3. Half, 1, 2, 3. Okay, got a lot of scribbles here, so let me just make sure that my parabola is nice and dark. I'm going to grade your points, so make sure I can see your points clearly. Okay, make sure your parabola grows wider or wider. At no point does a parabola ever just go straight down like this. This does not make sense. Parabolas keep going over, over, over as they grow. Okay, that does not make sense. Make sure you have arrows. Okay, and then I did show in a prior video how you can check your work. So I'm going to take this point right here, which is 9 comma negative 5, and I'm going to see if it works. I'm going to plug in x value 9, see if I get negative 5. Okay, so into this equation right here. What's 9 minus 5? 4. 4 squared is 16. What's negative half of 16? That's negative 8 plus 3. It does make negative 5. This graph is correct. Okay. All right, the last one right here is going to go over how to write an equation. Okay, the first thing I'm going to do is write down f of x so I don't forget to write that on my paper. Okay, you have to have f of x or y equals. All right, let's see. I'm noticing that this graph, okay, is the square root function. So I have to write that down for sure. Sometimes people get so enamored with the transformations that they accidentally put the wrong function. Okay, so just write that down first. The second thing I'm noticing, okay, a regular square root function looks like this. Okay, but this function is shooting up, up to the left. So it seems like this graph got reflected this way. Okay, that's the y-axis. So I need to make sure when I write my equation that I include a reflection over the y-axis. Okay, and when you do a reflection over the y-axis, where do you put the negative? That's right, you put it inside the function. Okay, what else do I notice? It's not starting at the origin, right? So there's definitely some shifting. Okay, 1, 2, 3. It got shifted 4 units to the left, and it got shifted 2 units down. Okay, so I have to make sure I have those things in my equation. Okay, now let's study this square root function just for a second. The regular square root function goes up 1 over 1, but this one goes up 2 over 1. And then it goes up 2 again over 3. Sometimes people can look at it and figure out. Some people like to see the growth chart. So how does the shooting star usually work? Over 1, up 1, over 3, up 1, over 5, up 1, except this doesn't seem to be doing that, does it? It seems to be going up 2 over 1, up 2 over 3. So it's still doing the overs, except the ups are now 1s. The ups have all been transformed into 2s. Okay, what does that mean? What does that mean? It means that this graph has been vertically stretched, okay, by 2. It's taller than usual. The ups are the verticals. It usually goes up 1 over 1, up 1 over 3. Okay, so it should have looked like this. It's definitely taller than usual. Okay, I just have to get all this information into an equation and we'll be good to go. Okay, so the first thing I'll do maybe is draw a nice big radical sign. Okay, radical, check. reflect over y-axis, has to go on the inside. Check. It has to go 4 units left, and this is where it gets tricky. I'm going to use a red pen here. You have to make sure that you put this in parentheses with the negative factored out, okay, the way that we get it into ready form, because I need to say left, so I need to say x plus 4 in parentheses with the negative out in front. Okay, check. Down 2, that goes outside. Down 2, check. Oh, and let's also add a vertical stretch of 2. Vertical stretch goes out in front, and a stretch by 2 needs to get a 2. Okay, you need to be able to do all these things that we just went over. Studying graphs and writing their equations. Okay, taking an equation and drawing a nice graph. Okay, knowing the names of all the different functions. Okay, and then just some basic shifting left and right. Okay, I hope this helped.